example of a customer churn, so that we can learn a lot about how the different mechanisms within the Elastic Stack are working and how you get into it. So, but first of all, so my name is, again, Felix Wörsel. I'm solutions architect working for Elastic. And so talking to customers every day about their needs, about how they are using machine learning, how they're using the stack itself, how to collect the data, and how to solve the critical business issues our customers have. So always a good contact point. If you have any questions regarding the Elastic Stack, feel free to reach out to me. Whenever you have questions today during the call, feel free to put this into the chat. So Thomas and Philip will have a look into the chat, and we will answer the questions once before the demo is starting, and we will all have an open Q&A session at the end so that you can also ask all your questions. From an agenda point of view, we will have an intro into predictive analytics first. So why we are talking about predictiveness, predictive analytics, predictive maintenance. So why we are talking about those things, what is why this matters. So this is the intro that we will be talking about, and then of course we will have a deep look into real-time data analytics and how to use machine learning in those real-time use cases, and well, of course, how to do this with the Elastic Stack. How does this look like? And we will also have a look into the Elastic Stack itself. So I've prepared a little demo for you that I can show, so that you can not only learn from the slides, but that you also get an idea in terms of the tool itself. And of course, to not only talk about the theory, I also have some real-world examples for you, so that you see how really real companies are using the stack. So it really is worth to stay until the end. So I hope that everyone will be happy here, and so that that you get the information you need that you're looking for. So let's start with intro into predictive analytics. So DataOps is a good topic here because we learned already from Thomas that DataOps is talking about data, and that data is the new oil is a well-known phrase that everyone knows. And of course, we are also really into that space. So we, as Elastic, think data is the new oil, and we try to get all the data, analyze the data for you, and also bringing value into it. So really the important thing that Elastic can do for you is to help you getting value out of the data. So first, of course, getting the data in. So bringing everything into the stack, and then you have all the possibilities you need to analyze the data and to really do something with the data. One thing you can do with the data is predicting the future. The more history of the data you have, the easier it is to look into the future, to make a prediction about the future, and that can really help in many different circumstances. For example, to find out whether a machine will have a failure, or what is the probability that a machine will have a failure within the next, let's say, 24 hours. And if you know that there will be a failure, or that there is something that could lead into a failure, then you can use or bring this machine into maintenance before something is broken, before you really have a high spend to repair the machine. You can just use cheap maintenance, for example, and that's one of the reasons why predictive maintenance, for example, is really pretty important in the manufacturing space, because they can, at the end, they use the data they're collecting from sensors and all the different things to save costs. So if you're in the manufacturing area, if you're working in the manufacturing area, the thing I will talk about is to save costs, to save resources for your company. So why real-time analytics is important? So we see that our users, and also users all around the world, demanding more and more real-time capabilities. So it's not anymore enough to analyze the data from yesterday. It's like the newspaper, right? All right. So reading the newspaper from yesterday is already history. Reading the data from yesterday is also history. So you need to know the data in real time. You need to be able to collect the data in real time, and being able to analyze the data in real time. And everything without a big hassle, without a big challenge to get into this. So everything must be easy for you. And that's one of the things Elastic is doing for you, not only in the business analytics space, also if you do cybersecurity or other things, this is how Elastic can help you. So but today we are talking again a little bit focused on the manufacturing topic. And in manufacturing, the most common thing all people are talking about is IoT or OT or IIoT. So there are many different buzzwords around that. But what it really is collecting data. So getting the data, transferring the data, analyzing the data, and finally also getting value or getting money out of the data. And the data that in IoT is coming from connected devices. But again, using the Elastic Stack, it doesn't matter whether the data is coming from connected devices or whether the data is coming from bank transactions or whether the data is coming from logs or from application information. So it could be anything. We just need to bring it into the stack, and then we get all the possibilities we have, like the machine learning capabilities I will describe in a second, and use this for your use case. And how are we doing this? So if you not know the Elastic Stack already, so this is just to bring you all on the same level. So the Elastic Stack consists of 4 different components, which is Elasticsearch, which is the heart of the Elastic Stack, where all the data is stored, where the analysis power is into, where also the machine learning capabilities living in. But first of all, you need to get the data in, and that is done by using beats or Logstash. So beats are used to collect the data where it is. So for example, in the manufacturing space, we often see MQTT as a data protocol, which is producing data, and then we can use a beat to collect MQTT data and bringing it into Elasticsearch. Logstash is used to connect with databases or to pre-process the data. So whenever you need to do some parsing or some calculations on top of the data before you store it, then you use Logstash for that. Of course, it's not enough to only collect the data. It's also pretty important to being able to visualize the data, and that is done by Kibana. So Kibana is the front end. We always say the window into the Elastic Stack. So there's all the functionality we have is bundled within Kibana so that you can use it and that you can also easily use it. On top of Kibana, we have enterprise search, observability, and security. So these are our main 3 solutions. So the ability to search through data, to observe your application, your IT landscape, and making your applications more resilient. And finally, also the Elastic security use case, which helps you to protect you against cybercrime. I will not talk about the main 3 solutions today. I will talk about the other use cases that you can do on top of the stack without using the main solutions. But if you would like to learn more about the main solutions, you can have a look into ela.st/solutions. Sorry for that. So having a look into this link here, there you can learn more about the out-of-box solutions that Elastic is offering. So another talk from myself. So if you don't get enough from my voice, so feel free to listen also to this presentation. The Elastic Stack itself can run both as a fully managed service in Elastic Cloud on AWS, GCP, and Azure, and it can also run on-premise. So if you need to to keep the data on-premise, then you can do this on-premise using other technologies or just installing everything on your own. So everything is possible, hybrid environments, cloud only, on-premise only, everything is possible. So no need to, so whatever fits into your use case, we are prepared for that. So how are you engaging if you working with the Elastic Stack? So the first thing is you need to get the data in. So you need to store the data. So you process or you collect everything you need. Again, it could be MQTT, could be OPC-UA, could be other technologies like just simple grabbing CSV files or log files, could be to get data out of relational databases and making it available for the Elastic Stack. So doesn't matter what, but we need to get the data first into the Elastic Stack. We could enrich the data with everything, with any kind of other data. So we could, for example, call in Web API and making the data or enriching the data with other data sources. In the second step, we do the processing. So we do, let's say you have a gigabyte amount of raw data, but what you need for your machine learning, for your predictive analysis is only a small part of it, and it needs to be preprocessed based on the full amount of raw data. Then we do this using transforms. So we're transforming the data into the right shape, everything within the stack features, everything in real time or near real time, so that you get the value immediately when the data is created. And finally, we bring all the data into machine learning, into the machine learning capabilities, analyzing for anomalies, analyzing for probabilities of certain behavior, and then also triggering automation. So for example, we know that a specific robot is or has a high probability of having a failure. Then we can trigger automation, a script, to bring this robot back to the repair plan, so that we can maintain the robot and bringing it out again before it is broken. And all this can be done within the stack without the need to use other tools. Nevertheless, if you have other tools, then we can also integrate with it. So let's have a look into this single stack architecture. So already pretty deep, but for those who not know Elastic, so we always try to make to build it as simple as possible, but we could also do it pretty complex if complexity is needed. In this case, we show everything that is possible. So from the left-hand side, we see the data collection part. So we all the data sources we can collect with or we can collect from. So it could be network information, logs information, again, different protocols and different devices from the manufacturing space. Also all the IoT cores and hubs from the different cloud hyperscalers. We can collect this. We can also collect Kafka information, or whatever you need, bring it into Logstash or directly into Elasticsearch. And from there, we have all the box UIs, dashboards, alerting capabilities, machine learning capabilities to work on top of the data, and for example, also to do the automation and the incident response if there is any incident. So you see, if you decide to go with the Elastic Stack for those use cases, you get everything that you need out of the box. If you think about other solutions, it's often the case that you have to work with TensorFlow to make the machine learning model. You have to, first of all, think about how to get the data into your TensorFlow workflow. So maybe you need to build your own Python script to do this. So it's often a bit of complex to use other kind of tools. And for us, we try to make it available for everyone, so that everyone can get value out of the data, that everyone is able to collect every kind of data he or she has to really, again, getting the value, monetizing the data that we have, because data is the new oil, but it's important to make something useful out of the oil, or making something useful out of the data. And with that, let's jump into the machine learning itself. So why this is important and how it looks in the Elastic Stack. So you see our main claim here is operationalize data science for everyone. So it's really important to understand that we are not focusing only on the data science part. We are focusing on data ops, so to say. So really bringing together everything you need to work with the data and to make it easy for everyone to get something out of the data. So let's have a look into the different possibilities the Elastic Stack has in terms of machine learning. So in general, we are dividing between unsupervised learning techniques and supervised learning techniques. So unsupervised learning is though you don't need to label the data, so you don't need to prepare the data first. The only thing you need to have for anomaly detection is to have a time series data. So there need to be a timestamp within the data, nothing more. And then everything else can be determined by looking at the history, learning from the history, creating a model out of it. And whenever there is the current behavior is behaving different than normally or than the expected behavior, then we call this an anomaly, and this anomaly can be alerted, and the alert can be used for many different things. Another unsupervised learning technique is the outlier detection. So we're building clusters out of to determine what is normal. And whenever there is one data point out of the normal range, then this is an outlier. Could be, for example, if you're going back into the manufacturing space, you're producing 1 million products, and 999,999 have more or less the same metrics, so the same size, the same weight, the same whatever. But the one product that is out of quality, so that is not behaving like the others, is the outlier, and this is, for example, scrapped. So you need to put it into, we need to do it again, so to say. So you can't use it, you can't sell it to the customer. And the supervised learning techniques are a little bit different. So there you classify, so you train the model based on your data first. So you need to teach the machine learning model what you would like to get out of it. So this is typical for predictive maintenance. So you have a kind of 10,000 training data that has a class like needs maintenance or needs not maintenance within the data set. And using that 10,000 data points to train the model. And then whenever there is a new data point coming in, you're measuring this new data points against the pre-trained machine learning model, and adding the probability or adding the class whether this data point leads into maintenance or not. So this is typical for classification. And a regression base is more or less the same, but you have another variable that is depending on all the other variables. So let's say you would like to predict the weather or the temperature, then the temperature is depending on many different other so-called features. So there are many different other parameters that are relevant to predict the temperature of tomorrow, for example, and this is something you can do with a regression-based job. And everything, again, is built in the Elastic Stack, so it's not you're not need to really deeply understand how machine learning works. You only need to understand how to use the wizards within the Elastic Stack. And for example, if you go with anomaly-driven alerting, the things that you can do there is that this is understanding seasonality. So let's say you have a metric that is different during days and during nights, or you have a metric that is different during weeks and during weekend, then this is a kind of seasonality that the machine learning model understands. Of course, it also reduces false positives because it is learning the normal behavior, and it has a moving threshold based on the normal behavior all around the day, and all around the week, and all around the month. And comparing this with simple threshold-based alerting, you usually have a lot more false positives, or a lot less false positives if you work with anomaly-driven alerting here. Of course, it also helps to for other to not changing the thresholds manually. So let's say something is changing on the metrics that you would like to observe and would like to get alerted on, then the machine learning model is still learning this. So it's learning also the new behavior, and you don't need to do something manually to do this. So the machine learning model is doing this automatically for you. These are all some of the things machine learning can really help you with. And so this holds for every kind of machine learning or anomaly-driven use case, not only for Elasticsearch, of course, but yeah, this is something which we try to make really easy for you. And finally, if you have alert created, so let's say any critical anomaly should be an alert for you, then you can trigger something based on this alert. So you can trigger a messaging service like email, like chat. You can trigger an issue tracking system like Jira, but of course you can also trigger some process automation. So bringing the robot back home, or restart a server. So blocking someone from the firewall. So these are all things that you could do based on alerts, or automatically, and don't need to do something on your own. And to make sure that you have as less false positives as possible, machine learning can really help you here. So let's have a look into some use cases from three of the areas we have seen before. So one is anomaly detection, and here you can find uncommon problems within the production process. So let's say you are observing the vibrations within a machine, and so they are usually in the same range, and suddenly something is failing, then the metrics look different, and then it's an uncommon problem for the production process that you can get alerted on. So this is something you can do with anomaly detection. You can also think about traffic situations. So if you think about smart cities or something like this, then this could be also a use case. Of course, also suspicious activity within network environment could be something. Classification, we talked about that. So typically for everything that is predictive maintenance, our main topic today. So doesn't matter whether it's machine, robots, it could be also cars, trucks, trains, everything that needs maintenance could be observed with the predictive maintenance classification model. And you can also determine whether a device works correctly or not. Outlier detection could be something to have a look into which products are unusable based on the production sensor data. Also, another use case is to have a look into the into your data and to try to find fraudsters. So fraud detection is another big use case for outlier detection. It's pretty obvious, I think. So again, today we are talking mostly about this use case. So about the predictive maintenance and how to get this done. Also about predicting customer churn, for example. So we talk mainly about the prediction. But I will quickly go through the anomaly detection just to give you an idea about machine learning also for that use case. So what you do, you get time series data into Elasticsearch. So it doesn't matter which kind of time series data. Then you put this into the machine learning model. The machine learning model is giving you data back, and Kibana is visualizing and alerting based on the data. So it could look like this. So we see the darker blue area in the background is the foreground is the current data, so the actual data. And the lighter blue area in the background, that is the machine learning model. That's what the machine learning model has learned. So you see it learns that the normal behavior is within this range. And whenever the darker blue line is within the lighter blue background, then everything is fine. But if it is out of this range, so we see this here, then there is this red dots created, and every red line means that there is an anomaly. And this is what anomaly detection is doing for you. So it checks whether something like this or whether something like this, something like this is normal for the system or not. And if it is normal, then you will not get any alert. And if it is uncommon or an anomalous behavior, then you get an alert out of this. And of course, it is learning again and again and again. So always try to get the best results also in future. So whenever something is changing, and also it is predicting, so it learns a lot, and then you can also predict how a specific metric is going on. And usually the prediction should be fine, and only if the normal behavior is out of the prediction, then this is an anomaly and you get an alert like this. So you operationalize the machine learning data. Now, let's have a look into the data frame analysis. So data frame analysis is the buzzword or the category of regression and of the supervised machine learning techniques like regression and classification models. And here I would like to guide you through an example of customer churn. So how to predict customer churn. So also for just to give you an idea. So what we would like to know is how many happy customers and how many churned customers we have, and to predict this. So the first thing you usually do in a machine learning project is to define the problem, or to find out what you would like to learn. So in this case, you would like to learn whether a customer what is the likelihood that the customer is churn or not. And the proposed solution is to do this with a machine learning model. We do this based on many different raw logs from different data sources. So we collect, for example, the amount of calls that the customer made to a support center. We checking how the customer has behaved in the application, and many different other things, putting this together and try to find out more information about the data. So the first thing is we need to construct the data set. So finding relevant data sources, finding out how to collect the data and bringing it into the Elastic Stack. And the second step is to transform the data. So we have a couple of raw data like this. So we have a specific customer who is using a specific channel, for example. In this case, it's streaming data. And then we're transforming the data to find out well, how often the customer is watching movies, how often is he watching films or TV shows or whatever, so that we get a better understanding in terms of high-level metrics what a customer is doing. So, and finally, we have another index based on the customer ID. So we collected the raw log data, transformed this data into a customer-specific index so that we have metrics for each customer and know what each customer is doing. And based on this data, we are now able to train the machine learning model. So in this case, we have a couple of things here, and we want to predict our churned field here. So first of all, we train the model by using, let's say, 1,000 customers and saying, okay, this customer has churned, this customer has not churned, based on the data we have, we already have. And then in the next phase, so after we trained the machine learning model, we now would like to get a new customer in and predicting whether this customer will churn or not. So we get a customer C, and the customer C has this features or this parameters attached to it based on the logs that we collected. And then we can, the machine learning model will predict the customer churn based on the likelihood that the customer will churn. So in this case is 97%. And with this feature influence here, so this customer will not churn, will churn. So the likelihood that the customer will churn is 97%. So, and all the things I have showed you is being done within the stack. So no need to leave the stack here. And so that you also believe me, I will show you, I prepared a little demo also for the manufacturing space. But now this is a good point to answer some questions. So whenever, if you have some questions about machine learning in the Elastic Stack, put it into the chats now, please. And let me have a look into the chat whether there is a question that I can answer. So it looks like there is no question so far. I will give you another second. So there is a question from Philip whether we should use specific ML nodes in Elastic. So well, to test everything, so in Elasticsearch we have specific rows that each nodes can have. So it can be a data node, can be an ingest node, it can be a coordinating node, or it can be a machine learning node. But one node can also have multiple rows. So in smaller use cases, we usually say that you can put all the rows together, so you don't need to have a dedicated machine learning node. However, the best practice is to have a dedicated machine learning node that is, and the hardware below this machine learning node is more focused on CPU, because the machine learning algorithms that are running needs more CPU than a normal Elasticsearch node. So for bigger setups, I would say definitely yes. Also, if you're using Elastic Cloud, definitely you have to use a machine learning node. But for smaller setups, you can also run everything on the same node. Okay, let's have a look. It looks like there are no other questions. So let's go into Elastic. So we are now here in Kibana version 7.12. And you see there are a lot of things possible here on the left-hand side. So especially from the data analytics point of view, so you can discover the data, which means you can search through the data, you can visualize the data in dashboards and in Canvas. Canvas is more like a presentation style or an infographic style. Dashboard is more interactive. You can visualize data on maps, you can do machine learning, and of course also not only visualize on top of dashboards, you also have to have a collections of visualizations, and that's in the visualize library. And there are many other functionality here, but I will focus on machine learning now. And within machine learning, we see that there are all the functionalities here. And the first thing we would like to do is to analyze our data source. So what we do is we select an index pattern, which means selecting the data source we are looking into. And I prepared a data source called APS. It stands for air pressure system. So this is the data we would like to look in. And if and this data comes from Kaggle. So Kaggle is an application that is providing data sources for you and also making some machine learning competitions. And I just took this machine learning competition from the APS system, which was from trucks, from Scania trucks, and then put it into Elasticsearch and try to get something useful out of it. So it's real life data from Kaggle. It's a bit prepared for this kind of use case, but it's everything is real here. It's not that we that I prevented or that I prepared or mocked the data. So let's have a look into this. So it's really also a bit of obfuscated here. So we see the naming of the fields are a bit hard to read. So AA is B0, so nobody knows what it means, but we can see the distribution and what is into. So we see in this field, we have many different distinct values here. The distribution looks like this. So we can get a quick understanding of the data we are seeing here. And of course, this data also consists of a class. And the class is just needs maintenance or not. So this is the field we would like to predict. But to be able to predict this field, we need to train the machine learning model first. So you see we have 60,000 data points here or documents within our index. And now we would like to go into the data frame analytics and making classification analytics. So we're just clicking here. And now we're going over to the data frame analytics. We would like to build a classification model. So again, we would like to predict something. Predict a label, which is a class. So we're just clicking on this. We already selected our data source here. And the first thing we can do is we can filter it down a little bit if we like. So usually you filter out data that is not fitting into the model or not really fitting well into the model. This can be done directly here within the UI. But for now, for us, in our use case, we would like to keep the full amount of data. You can also have a look into the data itself. So you see what is into here in all the different fields. So again, in my case here, the field names are not really speaking for themselves. So I don't have any clue what they are meaning. But I know that there is the class field here, which is my dependent variable. And then these are values from sensors here different sensors that are measuring the air pressure system. So this air pressure system has more than 160, more than 170 different sensors that are attached to him, and that are sending data to the central observability station. And we would like to find out whether a specific truck or specific air pressure system needs to go into maintenance. And we do this by calculating or by predicting this class variable here. So we take everything, every field into account. And we also see again a bit of distribution here. We can also use other fields just to get an idea about the content of the specific fields. If you don't have any idea about the data source itself, it's not really helpful, but usually you have. So if it's your use case, you should know what data you put into it. And then it's pretty good to have everything already here, so that you just get an idea about what you're putting in. You can also define how much data you would like to use for the training and how much data for the for testing. So we also like to test that the model we have trained is working well. So in this case, we're using 80% of the data to train the machine learning model, and then 20% of the data to test that the trained machine learning model is working well. Next thing is additional or advanced configuration. So if you feel that you would like to change something in to change how the machine learning model below is working, you can do this within these configurations here. But for me or for my use case, it's totally enough to work with the defaults and do not have any insights into the machine learning model itself. So we continue that. We have to give it a name. So call it DataOps ML meetup. And I could give it a text, so doesn't matter really for today, and then nothing more to do than just creating it. So you see there are 8 phases that it needs to run through, so it took some time. Like always in those things, in those talks, I prepared something for you. So I made this training already here, and we can have a look into the results. So I made exactly the same here, but this is already predicted here. Let's wait a sec. So we see I used the classification on top of the APS training data, so exactly the same with 60,000 docs evaluated. And now the first thing we see is the model evaluation. So the system is trying to tell us whether the prediction was working well or whether it was not working well. So we see the actual label, which is the label in the data of the test data, and we see the predicted label. So this is the thing the machine learning model has predicted for you in terms, and then it has, so the confusion matrix is checking whether the predicted results is the same as the actual label that it found in the test data. And we see in 100% of the cases, if there wasn't a failure, also the machine learning model said there is no failure. In 97% of the data, the system or the machine learning model was able to predict that there was a failure, so 1-1. And only in 4% of the cases, the machine learning model say, oh, okay, there was something, but it wasn't something. So in this case, 4% of the trucks had to go into maintenance, but we didn't find any issue. But usually, so in a normal behavior without using machine learning, this number is much, much higher because they use scheduled maintenance cycles. So for example, a truck is going into maintenance every 4 weeks without knowing whether something is broken or not. So in this case, we can run trucks much longer until they are in this category. And also if they are in this category, then it's only the case that it's going into maintenance and there is nothing, but it's much better than there is something and it's not going into maintenance. Of course, you can also check feature importance, for example. So getting more indication about what is the field here in the data source that is really putting value into the machine learning model. You get all the data here, but the most important thing is that it's pretty easy here to understand whether your machine learning model is working well or not. Now we trained the machine learning model. We tested the machine learning model to know whether it's working well. We see it's really working well, so we are close to 100% correct predictions. And the next thing we need to do is we take this machine learning model, and whenever there is new data coming in, we use this machine learning model and putting the class next to it, so not knowing the class before. So really bringing value into new data. And the way we do this is we go into ingest node pipelines. So this is every data or every document that is coming in needs to or can go through an ingest node pipeline. And then we're creating a new pipeline, calling it predict maintenance, for example, maintenance. And we're adding a processor to this. And the processor we need to do is the inference processor. So inference means getting data in and comparing it to the machine learning model. So we need to put in our model ID here, and which is the target field. And we can do some optional configuration, but the only thing we need to do is, okay, we would like to get data, whenever there's data coming from our APS system, we're putting it through this pipeline. This pipeline is applying it against the model ID, and then we have the class attached to the data that is coming in, and then we can use this data in our dashboards, in our alerting framework, whatever we need. I see the question from Philippe why there was the sum of 101%. This is usually rounding issues. So we show full numbers, and it was rounded a bit. So that's why it could be that there is 99 or 101% based on how we rounded the numbers. So nothing special. It's like every other system. Okay, so this is how to configure the processor. You just add this, create the pipeline, and then you are done. And every new data that is coming in has the class attached, and then you can use it. Yeah, that's all that I would like to show you, because it's nothing more that you need to work with machine learning here in the stack. So let's switch back to some real-world examples. So customers that are already using this kind of technology. So the first one is Play. Yeah, it's probably known to you as you're from Poland. So they are really using a machine learning, especially the anomaly detection, pretty often and pretty intensive. And they checking the radio links and whether they are working or not. And it's really important for them to know when there is an incident, and they do this automatically by using the anomaly detection in the machine learning stack. Another real-world example is Shell, so which is a big power supply company, and they really use Elastic for predictive maintenance of their facilities. So they collecting time series data in real time and bringing this into their ML models and trying to predict whether something is failing or not. So for example, when a compressor is failing, then they bring it into maintenance or they can predict whether it's a downtime, and then they can do something against it, to do something to mitigate the issue. So really important for them to have the predictive maintenance capabilities within the stack. Another one is CGI, so they using this to predict prices of electricity. So they try to predict whether the price in the I don't know the English word, electricity exchange is increased, it's not increasing, and then they building their business decisions based on this data. And last but not least, it's Karton. It's one of my customers. So they're collecting many different sensor data from their production process, different vendors that have produced the things. So for example, ABB, Honeywell, Siemens Systems, collecting the data using OPC and bringing it into Elastic. In Elastic, they do machine learning, they observing specific behavior of the data, and with the target to find out whether the resource consumption is on the good level. So when the resource consumption is not fine, they're producing a lot of crap in their factory, and so that's why they really need to be quick in checking that the resource consumption is fine. And as they saved a lot of money by really checking and predicting that the values are fine now, and that they're also fine in the near future, so that they can really save resources and also reducing the scrap rate within their company. And with that, I'm opening the open Q&A session. So the second one,